Hi, everybody. How's it going? All good? Good. Good. So, my talk today is called Modernizing Ruby Systems with a Faster Age Framework. And there are three topics I wanted to talk about today. First, I'll talk a bit about Rails. We all use Rails. I guess we all love Rails. Do you love Rails? Yeah, I do too. But today, I will specifically focus on things I consider problematic. Next, I will introduce you to the Rage framework that attempts to fix some of these issues. I'll talk about its features and some architectural traits. And finally, I'll tell you about my experience integrating Rage into two very different applications, and I'll share the results of comprehensive load testing of these applications. So let's get started. But before that, I'd like to give you some context and talk about how I got here. I've been in the industry for more than 12 years, worked with a range of technologies starting with C++ and ending with Kotlin. But throughout my career, one way or another, I've always worked with Ruby. Now, I'm a contractor, which means I can work with many different companies and applications in a small amount of time. And one thing I noticed is that not only fewer and fewer companies decide to choose Ruby to build their products from the ground up, but even companies that already have Ruby applications choose to deprecate them instead of continuing to develop. Every decision has a reason behind it, and I was curious to understand what could be the reasons behind these decisions. I'll go into more details as I proceed, but a more general problem I see is Rails monopoly. One thing I like about other technologies is that there are many different frameworks. Frameworks that pursue different goals, that implement different ideas, frameworks that are built by people with different views. In the Ruby world, though there are many different frameworks, Rails is essentially the framework. Whatever Rails core team adds to the framework quickly becomes the way to go. Whatever they choose to ignore comes to nothing. And because of this, the Ruby ecosystem is falling behind. And when I see how Rails and consequently Ruby decline in popularity year after year, I naturally ask myself, what's wrong? Like, clearly there's something wrong, right? But what is it? What are the reasons behind it? The Rage framework is my attempt to answer these questions. So hopefully that gave you some context. And with that, let's proceed and talk about issues with Rails. And to me, the most obvious one is performance. On this slide, I have the results of a benchmark of a simple hello world test application. The column on the right represents a bare rack application. And while we don't usually use rack to create web applications, this number serves as a reference point. It shows how much of an overhead the framework of our choice actually adds. The column on the left represents a similar Rails application. There's no business logic, no database requests, no advanced Rails features used, even logging is disabled. Yet our application becomes almost 40 times slower by just adding Rails to our stack. It's a good time now to pause and consider whether you think it can be justified. I think it can't. Now, performance is a controversial point because there's an opinion that says framework performance doesn't matter. The bottleneck is always the database or the business logic, so why bother? Well, believe it or not, generally I agree with this statement. It makes sense. Framework performance doesn't matter that much. Still, I'd like to make some points. And first of all, when it comes to Rails, the price we pay in terms of performance is just way too high. The thing about this number is that this is the best performance we could get. And it doesn't matter what we do. We could cache all our data in memory and never send a query to the database, which is quite a common scenario for API gateways, for example. We could write all our business logic in C, it wouldn't matter, as this is the limit Rails imposes. Do we have to introduce this much of an overhead for what in essence is a relatively simple DSL on top of rack? Does it have to be that slow? Okay, Roman, we got it. Rails is slow. Nobody's arguing with that. Does it actually matter? Well, I think it does. And one of the reasons for that is market demand. Fastify, which is highly focused on providing the least overhead, is one of the most popular Node.js frameworks. Fast API, which among other things is focused on high performance, is used by every fourth Python developer. With this, it just doesn't matter whether performance is an important metric for a framework or not. There's a demand for high performance, low overhead technologies, and I don't see much value in ignoring this demand. All right, that was the performance. The next issue I want to talk about is Rails' full stack approach. I can see nobody's trying to assault me. That's a good sign. Usually, this is considered one of key strengths and core features of Rails. In theory, you don't need anything except Rails. You can even write front-end with it without a single line of JavaScript. Just run and generate a command, and you're up and running in no time. I think that such approach makes sense in two cases: hobby projects and rather impressive articles titled "How to Build a Web App in 15 Minutes." When it comes to professional web development, it's actually fine to spend more time setting up the project and defining the architecture. It's actually fine to use different tools for different tasks. And it often results in a more flexible approach. A related issue here, the front end. If I had to choose one word to describe front-end solutions in Rails, I'd probably choose unreliable. There's something new with almost every Rails version. Now, new solutions are always a very interesting and exciting thing to implement and work with. But on the other side of this excitement are companies. Companies that usually don't find this exciting. Companies that spend big amounts of money adopting every change. Companies that are just looking for a stable and reliable framework to build their products with. And I can't really call Rails stable. Between even minor versions, there are dozens of changes inside the framework. Every Rails upgrade takes lots of time, often introduces bugs, and sometimes requires rewriting and refactoring. So my point is, the less we depend on Rails as a Swiss Army knife type of tool that does everything for us with its magic, the more simple and stable code base we will end up with. The last issue I want to briefly touch on in regard to Rails is its ignorance of modern Ruby. The Ruby core team does a terrific job improving the language, and I think it's a shame that some of their efforts are being ignored inside the community. For example, Ractus, an abstraction that provides true parallel execution without the burden of the global interpreter lock, completely ignored. Fibers, another fantastic feature I'm going to be talking more about today. Essentially, it allows to pause a piece of Ruby code right inside a fiber, and then resume this code later. In theory, it allows to create Node.js type applications that do not block while waiting on I/O. Completely ignored. So with this, let's proceed to the next part and talk a bit about the Rage framework. So what is it? On this slide, I have two code snippets. The code snippet on the left is a regular Rails controller. It follows a usual pattern of using a before action to find some data. It implicitly halts the execution if the data is not found, and it renders JSON. The code snippet on the right is identical, and the only difference between the two is the parent class for our controller. By looking at it, you can understand that the controller on the right is actually built using the Rage framework. Hence, the first feature, Rails compatibility. Rage is designed to be a drop-in replacement for Rails in API mode, and it exposes the very same API that behaves in the very same way. Before actions, accessing parameters, using active record, everything works out of the box exactly the way you would expect it to work, using the same code you would use in Rails. To make this controller work, we would also need to update our routes to match the URL with the actual controller. Again, the code snippet on the left uses Rails, and the code snippet on the right uses Rage. Yet, the actual route definitions are exactly the same. So that's the first feature. What others? Well, it's fast. While providing the exact same API as Rails, Rage has much less overhead. This is the same benchmark we looked at on the first slide, but with the addition of Rage. In this test, Rage performs almost 24 times faster than Rails. Another feature, fiber-based concurrency. Rage wraps every request in a separate fiber and implements a custom scheduler that pauses the fibers once they encounter blocking I/O, delegates waiting on the I/O to the operating system's kernel, and then resumes the fibers once the I/O is ready. The result, let's say we have an application that sends an HTTP request to another application and receives a response 1 second later. For Rails running in 5 threads, it will take roughly 25 seconds to complete 100 requests. For Rage, it will only take 1 second. The last feature I want to talk about is one of Rage's architectural traits. The basis of Ruby web development is a standardized interface called RUC. The idea is that there are multiple frameworks and there are multiple servers. And you're free to use any server to power your application as long as it implements the RUC interface. I don't think such approach makes sense, at least not anymore. We don't need multiple application servers. We only need one. And Rage introduces a tightly coupled architecture. It ships with its very own server, which is a part of the framework. It still uses RAC to be compatible with all the custom RAC middlewares. But you don't need to choose whether you want to use Puma, or maybe Passenger is better these days. One of the benefits of such approach is flexibility. By being in control of our own server, we can now move some lower level code to the actual server level, or even break the RAC protocol while still remaining compatible with the custom RAC middlewares. All right, that was a lot of talking. Let's look at actual numbers. I'm going to share the results of integrating Rage into 2 very different Rails applications, and then load testing them. So let's look at the first application. It's an application you could probably call an I/O-bound application. It makes database calls, uses Redis a lot, but most of the time it spends talking to other applications via HTTP and waiting for these applications to respond. Now, this use case is the best case scenario for Rage. With the help of the fiber scheduler, Rage doesn't block while waiting for these HTTP requests to finish, and in theory can be much more effective than Rails. So what does the test say? Here I'm going to share the results of a stress test, which was running at a close to peak load for 1 minute. So in 1 minute, our Rails application was able to process 1100 requests with a P95 response time of 410 milliseconds. This same application, but with Rage integrated, in 1 minute was able to process 9,000 requests with a P95 response time of 250 milliseconds. So not only were we able to process 8.5 times more requests in the same amount of time, the application was also much faster to respond. What this data actually means? Well, first of all, if we can now process 8.5 times more requests with the same hardware, means we need 8.5 times fewer servers to process the same amount of requests our application is currently capable of processing. Another use case, traffic spikes. The thing about traffic spikes is that they may be quite difficult to handle, yet it is crucial for every company to be able to reliably handle traffic spikes. Imagine an influencer sharing a story about your application, and out of nowhere you have hundreds of users trying to use it. Or a network glitch, after which your service receives several times more messages than usual. This data shows that with Rage, we can now process traffic spikes much more reliably. So that was the first application. Let's look at the second one. This application is very different. It doesn't make any HTTP calls. Instead, it only issues very fast database requests and spends most of the time inside the Ruby layer. Now, same as the first application was the best case scenario for Rage, this application is the worst case scenario. The amount of time the application spends waiting for the database to respond is almost negligible in comparison to the time it spends inside Ruby. And in theory, with this application, Rage should perform similar to Rails, because the bottleneck is somewhere inside the application, whether it's active record or notoriously slow active model serializes. So what do the tests say? While our Rails application was able to process 11,000 requests, the same application with Rage integrated was able to process 30,000. So even in this case, with Rage, we were able to process 2.6 times more requests while responding almost 100 milliseconds faster. If you're wondering how this is possible, the answer is Rage's connection pool. Rage has its own connection pool implementation, and it can swap active records connection pool with its own implementation, effectively eliminating a big chunk of active record overhead. So, what do you think? Do you like the numbers? Because I love what I see. Okay. When talking about Rage, I happen to focus on performance a lot. It doesn't necessarily make me happy because Rage is more than just about the performance. And in fact, I see the fiber-based asynchronous I/O as the main feature of the framework, not the performance. Still, a valid question is it actually relevant? There are not many high-load Ruby applications, so is it relevant? And that is indeed a valid question. If an application peaks at 100 requests per hour, which is a very common scenario, Rage won't change much here, at least from the performance standpoint. But what if we think about companies that use .NET, Java, maybe Go? They could use Ruby. In fact, they want to use Ruby because Ruby is a great high-level technology that allows you to iterate really fast. It's a technology with a big and seasoned community. But they look at the Ruby ecosystem, they look at Rails, and what do they see? Performance is a concern. Maybe we'll need to scale, maybe not, who knows. But it's a concern, it's a risk not everyone is willing to take. Creating IO-bound applications is another concern. Is it not possible with Rails? Of course it is possible. But again, it's another risk not everyone is willing to take. The game of adding new features and approaches while simultaneously deprecating the old ones is another concern. And this is what drives companies away from Ruby. And I believe that Rage could be a missing piece here, a technology that can do less, yet is more versatile. Performance is not a concern. It will never become a bottleneck. And in fact, it shows that Ruby is not slow. It's actually fast enough. Creating IO-bound applications is also not a concern. We can now process hundreds of requests simultaneously, and we don't need to do anything to support it. Any database client, any HTTP client, it just works. It has a narrow and well-defined scope, which means it's stable. And it's the same Rails syntax probably close to 100% of Ruby web developers are familiar with. Still, despite really great results, if you ask me, Rage is a very young project, and we need help. As you can see, there are many very, very exciting things going on. And if you, like me, love Ruby, want it to become more popular, if you want to improve and modernize the Ruby ecosystem, please join the community. Join the team, and let's build something awesome together. That's all I had for today. Thank you.